We are ready to start. Thank you everyone for coming to this 20-minute sessions where I will present you for 3 different ways of building a modern data warehouse in Azure. So my name is Just. Many of you probably know me for doing Power BI stuff, but I have a secret. I also do a lot of Azure stuff and data warehouse stuff. I've actually been building data warehouses in Asia for the last 6 years, mostly on an architecture level. But this session, what is a modern data warehouse? Yeah, it is actually just a fancy word of having a data warehouse in the cloud. That's where I put into the name. So building a data warehouse into the cloud, and how can we do this? I have 3 different solutions for you today to go through. And as we only have 20 minutes, this will be on a high level. I will show you some diagrams and not dig so much into the details. And so if you have any questions, please delay them to the end. I will stay, or you can come and grab me later on. I will be here also to the party tonight, and we can discuss this if you want. And then, of course, ending off comparing the 3 different solutions. Of course, there's lots more options than just these 3, and we can also combine them in different ways. I have chosen these 3 for this session, and also the agenda for me is that Microsoft, if you go in on this site, there's a lot of different diagrams of building. I think there's hundreds of diagrams of building solutions, and also a lot of different ways to build a modern data warehouse. This one is the one that is about enterprise data warehouse. So if you look this up, you will see that Microsoft actually put in the most expensive components that you can buy in Azure when building a data warehouse. So my goal today is to show you how we can make a more affordable solution that still can scale, where we don't need these expensive components, like, for instance, the SQL pools in Synapse, the Azure Analysis Services, and also the Apache Spark pools. These 3 are very, very expensive. If you go to this link, you can actually go in and go to the pricing calculator, and here you can see what this solution costs. It's also, of course, it really depends. This is just an overview for Microsoft, and it says that it will cost you over $2,000 a month to have this running. Of course, we can scale up, we can scale down, so you have to go in this calculator and adjust the numbers for your needs to get a more proper price. But I will try and show you 3 different ways to build something that's more like $100 a month instead of this. So, first off, this is the solution from Microsoft. I just changed the slides so I can present them in a little more nice way. And you see at top, this is just the classic solutions we are building, an ETL solution. But of course, Microsoft came up with some new names for this. So now it's not ETL anymore. Now we are calling it ingest. Yeah, that just depends. Then we have store and transform. For me, that is actually where we are going in and having a ELTL instead. And instead of having ELTL, we have ISTS in the terms in the Microsoft architecture. I have just adopted these terms, but it is basically just an ETL solution we are building here. So, taking this solution, then we actually can do the first trick to make it even cheaper. And if you didn't see it, it is removing Azure Analysis Services and replacing it with Power BI. Because nowadays, we can use the XMLA endpoint and just deploy our models directly to the Power BI service. It requires premium, so you need to have that in place, either premium per user or a premium capacity to use this feature. But I actually have a blog post where I write about how you can come around this, still using Pro, but using the A SKUs that you can buy in Azure. So that way we can turn on the XMLA endpoint, deploy our models, and turn it off again, and only spend very few dollars and having that possibility to deploy our enterprise data models directly to Power BI service. So with that in place, and actually also, this is, I don't know why the official enterprise data warehouse solution shows the other one, because this is the recommended solution from Microsoft from now on going forward, is to deploy your analysis services model directly to Power BI service and not using Azure Analysis Services. And Azure Analysis Services is one of these components that is really, really expensive to use, because you have to have it turned on all the time, at least if you want to have your users being able to browse the reports 24/7. So that way, if we have, if we use the Power BI service, we can do it a lot cheaper. And then in the other end, we have getting the data out of the data sources. That is our ingest or transform or extract part. And here you can see that we have Azure Synapse integration pipelines in Synapse. That is what it's called nowadays. It's just Data Factory in a new shelf. So in this architecture, there are some things that we might need to change, because we have Data Factory, and Data Factory is a really, really brilliant solution to ingest your data, and it's also cheap if you are using it right, not doing some real-time, only doing batch jobs in ingesting your data, and it can handle both the structured and unstructured data very, very well, and you can do it very dynamic. I'm sure there's a lot of session around that on this conference. So what I will focus on in this presentation is the middle part. What can we actually do to store and transform the data? What are our options if we don't want to use these very expensive tools? We can say store, that is just data lake, it's very cheap, but how do we transform the data in a more efficient way and more cheap way? So the first one, this is the one I tend to call the traditional modern data warehouse, because it is just the way we are used to do it, or at least I have used to do it, on an on-premise SQL server. So using a Azure SQL database and using the capabilities with T-SQL to transform our data. Then we have this discussion around how to store our data, at least our unstructured data, because a SQL server is really, really good with structured data. But the unstructured data, that can be a more tough one to handle. That's why I also put a data lake in the bottom, so that we can ingest these data there. But if you only have structured data, we can skip that part and just put the data directly into the SQL database. And if we then zoom in on this transform part of this model, then we can look at it this way, so that inside our database, we will have a couple of different layers in the architecture. I usually do this with schemas, have different schemas for the layers in the architecture. So we have a presentation layer. That's usually something I do just with views, not materializing in tables. Then we have the baseline. That is where we have our facts and dimension in a beautiful star schema way, Kimball way. And then we have the ingest data that is more raw, and how do we then transform the data from this raw format in ingest, that is more like the data we just pulled out of the source systems, into a star schema. And my suggestion here is to use T-SQL, simply writing some store procedures or some views. I have also a blog post and also a GitHub repo on this transform framework. I won't call it a framework, that's why I put it that way. But it is a starting point if you want to go this route. It is on my GitHub. I have a link on the last slide to that one. So that is one option of doing it the traditional way, just with the T-SQL and using an Azure SQL database. And the Azure SQL database also have this capability that we can scale it up and scale it down. So when I'm doing my batch processing, transforming of my data, then I can scale it up to a certain size. And then after, and that's first after I have processed my models, then I can then scale it down again and only pay a few dollars to have it scaled completely down. Because in this scenario, we don't have any business users going directly to the data warehouse database. They are doing all their analysis on the data models. Of course, if you have this scenario, then you need to figure out if you don't necessarily have to scale it completely down if you need these self-service users going directly on the presentation layer in this architecture. So this is one of the ways we can do it. Then we have the next one, and that is the data lakehouse. That is something that we hear a lot also on this conference. And in this scenario, we still use Azure Data Factory or integration pipelines in Synapse to ingest our data and store them now in a data lake instead. And there we can store both our structured data and unstructured data, and we can store it as CSV, JSONs, Parquet, Delta tables, whatever format that suits for us. But how about the transform part? And my suggestion here, if you want to go this route, this is using the Spark pools. And the Spark pools in in Synapse Analytics is also a service that you can scale up and scale down and only have it turned on. That service you can actually turn off completely. So turning up a cluster in Spark and then writing either, you can still, in Spark clusters, write your T-SQL if that's your preferred language for transforming your data, but you could also be a little more fancy and use PySpark. So coming from an on-premise world, this can be maybe a little bigger step to go on this route. And then, of course, when it's a lakehouse, we will land the data in the surf layer in the lake again. And from there, we then have the opportunity, for instance, using SQL serverless endpoint to have business users actually querying it 24/7 on the presentation layer, and also going directly there, and not only on the data models that we have been published to the Power BI service. So that gives a little more freedom for self-service users, and maybe also some more better performance. So this is one way. And then we have the last one, and that is going actually in a very opposite direction. And this is one I call self-service with Power BI. Data flows, actually, if you think about it, it is still a lakehouse you built. Because when you're doing and using data flows, and that is what I'm suggesting here, for the ingest part and the transform part is just using Power BI data flows to get the data in and transform your data with M language, or just point and click in Power BI data flows. Here you have the opportunity in Power BI to bring your own data lake. So you can actually attach it to your own data lake, and then this solution actually turns into a lakehouse. Also, just not using Spark to transform the data, but using Power Query in Power BI data flows. And here we just, in ingest phase, we not using data factory or integration pipelines in Synapse, but we're using a data flow. You can, of course, make still use integration pipelines in your ingest phase, but the transform part, that will be your data flows. And this solution here, that is the really, really cheap one, because you can use and do this with pro licenses. Maybe it won't scale that good to large volumes of data, but it is a really, really cheap solution. I'm looking forward to, as many of you probably know, Microsoft have now having the development teams from Power BI and Synapse working closer and closer together. So I'm looking forward to what this architecture might look like in maybe 6 months, where they are combining these teams and maybe opening up this solution even more to more possibilities. I expect we can see something in this. So next time I present this, might not look like this, because Microsoft have come up with something else for this, and maybe combining it some ways. That's just something I maybe think could happen. So if we then compare the different solutions, we can say, okay, how should I choose one of each of these solutions? And it really depends on a lot of different factors. So the choice is not easy. If we are familiar with SQL, we can use the two first options. If we are more into point and clicking, we can use the last option. But then, also depending on the developer persona, more self-service or more pro developer, the scalability in the data volumes, the Power BI data flows, Power BI data flows don't necessarily scale that good if you get trillions or billions of rows. Maybe it's better with only millions of rows, where the two other solutions, you can really scale them up because it's just a matter of scaling your Azure database up or scaling your clusters in Spark up, where you don't have this possibility in data flows to scale it. Also, one disadvantage I will say with the Power BI data flows is that the M language, the Power Query engine, only works in the Azure or in Microsoft environment. So you can't take this solution and then maybe shift it to a data lakehouse or to a traditional data warehouse, because it is Microsoft's own language. You can either portable over to another cloud. So if you want to have that flexibility, I will say use one of the two first. But of course, then we have the price and the monthly cost that is really at an advantage of that one. So what I will say is, it really depends, and it's not an easy choice to choose one over the other. And for that, it was my 20 minutes. So thank you for coming by and watching this session. If you have any question, feel free to find me on the conference or just come up here. And also, please, I have 4 more minutes. Oh, I saw this 1 minute. Oh, perfect. Then we can continue. I have more slides, so I'm prepared. We'll get back to putting in the feedback here. Question still later on. Pricing. This is a comparison of, just to show you, I have here the traditional modern data warehouse, how much that will cost. And of course, it depends on how much you scale it. But in this scenario, I have shown that it is scaled to a certain amount, certain hours a day when we do our batch processing, and then scale it down for the rest. And then, as you can see, also, I use Power BI embedded this ASQ to be able to deploy to the XMLA endpoint, and it's only up when I need to do a deployment. So $110 a month to run a solution, a modern data warehouse solution, and not these over $2,000 that Microsoft come up with in that price estimate. So that's a significant amount of saving. And I've been implementing this solution with a lot of customers, and it can handle hundreds of millions of rows. So don't be afraid of that it don't scale. Of course, that's just what I will say to that. And here are the links to some of the resources where you can actually also find and download this solution, both some data factory pipelines and also some SQL scripts to do the transformation of your data. And for that, I will then say thank you for attending this session, and go back here again.